They're trash. All right, here we go. First thing I want to look at is something called parabolas. All right. So you've seen parabolas before. Also, it would be helpful if you guys have that cheat sheet with the different graphs on it. Just have that on the side and look at your parabolas. But parabolas come in two forms. They're either x squared equals 4py or y squared equals 4px. Okay? Have you seen this parabola before this year? Quadratics are parabolas, right? Like x squared plus 4x minus 2 equals 0 is a parabola. We can have sideways parabolas as well if it's y squared. Now, with parabolas, there's only two important things on a parabola, okay? The two important things on a parabola are going to be your focus. Oopsie. You have a focus and you have a directrix. Those are the only two things we need to find. The focus is the same thing with the light refracting off it, bouncing to it. The directrix is where I flip it over itself. Do you remember on that front page of your notes, there's always like this drawing of like two cones, right? So a parabola is if I slice like that, you end up with two parabolas, one here and one here. The directrix tells you where to flip it over onto itself for that other parabola. You don't need to know that for the time being, but what you do need to know is how to find that. The good news for you is it's division. You're going to do one-step equations to find this, all right? So let's do two examples together. Then I'll have you guys do this worksheet in class. We'll go over it, and then we'll do the next thing that we're going to do. Sound good? So given our first parabola, let's do x squared equals 36y. Now our focus is P away from vertex, and our directrix is P away from vertex. For vertex, from vertex. This is all in your, on that one sheet as well. So basically, once I find P, I know everything I need to know on this piece. Once I find P. What's my equation for P? It's 4P. This is 36 equals 4P. So what's P equal? 9. Once you find that 9, that's everything you have to do with parabolas. You're pretty much done. All right? Because it's x squared, it opens like this. Right? So my focus is 9 away. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a bad drawing of it. So my focus. Now, how do you know if it's on the x-axis or y-axis for your focus? If it's x squared, it opens up and down. If it's y squared, it opens sideways. Right? So my focus would be 0, 9. Now my directrix is 9 away the opposite direction. So I'm going to go down 9, and that's a line. Isn't that a fun word, directrix? Directrix. So that's the line, y equals -9. Okay? So if you want to just even know that, if it's x squared, it's always y equals something, and your focus is going to be 0 something. And that something is whatever your p value is. One's going to be positive, one's going to be negative. Okay? You want me to see me do an x squared one really fast, like how you're going to actually do it when you do this beast? Also, if you look at your packet at the top, there's a little cheat on the last page of your packet. There's a little cheat sheet at the top that reminds you of this stuff as well. This is, I'm not gonna lie, this is AI slop. I just had to make this really quick. That whole thing, yeah, is all slop. Sloppy, sloppy, sloppy. What if I gave you x squared equals negative 8y? What's p gonna be equal to? Well, 4p equals negative 8, right? So p would be negative 2, right? Any questions how I found p? It's just 4p equals that number in front of your non-squared term. So my focus would be 0, negative 2. And my directrix would be y equals 2. All right? Don't overthink these. Find your p, plug it in. All right? Oh, we're doing great. I'm going to do one more example, then I'm going to have you guys do a few examples. What happens if I do this? Y squared equals 12x. That one's going to open sideways, right? So now for this one, my focus has to be in here on the x-axis, and my directrix has to be over here. Well, I'm still finding p. 4p equals 12. P equals 3. So this point would be, my focus would be 3 comma 0. And my directrix now is not y equals, that line is x equals negative 3. That's it. So here's what I would like you to do. All right. Hey, code word time. The code word is bark, bark. Yes, for my college algebra dogs. Code word is bark, bark for that free homework assignment. All right. Go to the next page, finding the center vertex. This is going to be the most straightforward, easiest thing we do all year, actually. It looks like the most complex. I'm going to do an example of each. I would jot this down somewhere, maybe on the side, the margins. So the basic circle equation is x squared plus y squared equals r squared. If I want to shift it, do you guys remember when we do shifts a long time ago? If it's in the parentheses, we do the opposite of what we think. We're moving the center point. So technically, if it's x minus h, that's right h. And then this would actually be up k. Because they're both on the left side parentheses, we do the opposite of what's in the parentheses to move it. Okay? So our center is hk. hk is center. And then I'm going to put a dash vertex because this works for parabolas as well. It's the same thing for all of them. It's hk is your center point. Okay? So now that looks like a lot. But these problems, I'm happy this is on the exam. Because think about, I'm just going to leave that up here while I do these. So if I have the circle x minus 2 squared plus y plus 3 squared equals 9, what is my center? What's the opposite of 2? Or negative 2? 2. Opposite of 3 is negative 3. That is my center point of that circle. Okay? The biggest mistake is to know you do the opposite of it, right? Does this even work with like ellipses? Like if I had x plus 9 squared over 81 plus y minus 8 squared over 100 equals 1. What's the center of that ellipse going to be? The opposite of 9 is Negative 9. Opposite of negative 8 is 8. That's my center. Again, it works for vertexes, ellipses, hyperbolas, circles. It's all the same thing. The hardest thing with hyperbolas is this. If you're left with like y minus 1 squared over 8 minus x plus 2 squared over 16 equals 1. What's my center? Just make sure that the x comes first, right? So it'd be negative 2, 1. All right. Bark, bark. If you guys would like, I forgot to give you the answers, try the worksheet I posted, and then I'll throw the answers on the board. All right, bark barkers, Bob Barkers. Here's the answers to that AI slop I gave you. If you have any questions, make sure you contact me. And I have one more thing to show you all, and it's going to be a step-by-step process. It's not going to be that bad, but just I would definitely write down the steps to the step-by-step process, and it's going to be done the same way every time. All right? So go ahead and go to the front page because it's printed in order, and we are going to look at completing the square. So we kind of skipped completing the square earlier, and now it's going to bite us in the fanny because we got to know how to do it. I'm going to do a problem that's not on here, so if you want to have it on the margin as a bonus. So let's say I have x squared plus y squared. Let's just make one up. Minus 8x plus 4y. Let's do that. Plus, minus 15 equals 0. All right? So that has an x squared and a y squared. It is some sort of conic section. I do not know what kind it is. Is it an ellipse? Is it a parabola? What is it? Actually, I can't tell you. It's a circle. It's going to be a circle. But now, based on this, do I know what the center point of the circle is? No. Is this something I can graph on my calculator? No. So whenever I see an equation like this, I'm going to have to complete the square. So again, I would have this down. It's a step-by-step process. I assure you that these problems aren't that bad, okay? That's the reason why I'm going to make sure we do it. Our first step, step 1, is going to be group variables together. All right? So what I mean by that is I'm going to get my x's next to each other. So x squared minus 8x need to be next to each other. My y's have to be by each other. I'm also going to leave a space here. I'm going to leave a space here. You're going to see why. You don't have to leave a space, but I'm going to. My y's have to get together. All right? And I'm going to leave a space. Okay? And I'm going to put equals 15. So part of that is my constant needs to get moved over. I cannot have that on the left side. It will not play nice with the variables. If you are a constant, do you want to be hanging out with x's? No, that's not a good idea. Don't ask why. No. Keep the questions and your x's on the same side. You need to be over here and just being constant with your life. All right? That's good advice. So now, we got our variables grouped together. Next, we're going to do something. You might have seen this. You're going to divide by 2, then square. Divide by 2, then square. Divide what by 2? This term. This term. I'm going to divide it by 2. Negative 8 divided by 2 is negative 4. Then I'm going to square it. Okay? Divide by 2, square it. Divide by 2, square it. Divide by 2, square it. Divide by 2, give 2, square it. Divide by 2, square it. Every time. The nice thing with these problems is we don't see this much. You do it the exact same way every single time. There's no, sometimes you do this, sometimes this is every time, divided by 2, and you square it. Then 3, add it to both sides. Add what? I know I'm using these. You're going to add these to both sides. So if I put a plus 16 here, what do I have to do on the other side to keep it equal? Add 16. All right? If I add a 4 here, what do I have to do this side? Add 4. Okay? We're one step away from being done. What color should I use for this one? A bark blue. I already used that one. A beautiful, ooh, a pink. All right. We're going to factor and win. We're going to be the state champs of this problem. All right. Is this thing factorable now? With the plus 16? Yeah. In fact, that negative 4 is my factor. This factors into x minus 4 squared. The divide by 2 part gives you what's factored into. You don't have to think about it. The process lets it factor. That's why it's called completing the square. You're making it into a binomial perfect square. Okay? Where did that negative 4 come from? When I divided by 2. Then what's this one going to factor into? Y plus 2 squared equals 35. That's a completed square circle problem. All right? That looks like a lot. This is a type of problem that if you do a bunch of times, you find actually they're not bad. You guys want to do one more together? Let's do one more together. Let's do one from the worksheet together, and I'll have you guys do one, and then we'll be done for the day. Yep. I'm going to leave this up here. This is very vague and terribly written instructions, but you know what? I'm a terribly vague instructor, so. Mm-hmm. I concur. I concur. That's fine. I like the color coding, though. Did you guys know that color coding your notes in mathematics can increase memory and ability by up to 20 to 40%? Yeah. All right, we're fine. Let's do one more together. It looks like a lot. Nice thing is if you have notes for this, or if you are sitting there looking at it, it's not as bad. Let's look at number 1 from the worksheet. Let's use purple because I like purple. So it's x squared plus y squared plus 6x minus 4y equals 12. Lucky for us, we're already away from our x's. That's good. What's my first step say to do? We need to group the variables together. Your x's stay together and gossip about you. Compare notes about who got treated better by who. Your y's get together. What should you leave here, though? This is a bonus. I would leave a space there, right? Because we're going to put a number in there eventually. I don't know. I had a professor, shout out to a Delta professor, Nathan Blecky, who, when he taught this, did something crazy with like a bat wing symbol. I just never remembered what he did, but involved Batman. I wish I'd remembered, because that's when I learned how to do this. And plus y squared minus 4y space equals 12. Just remember, blank space was double platinum, so you need 2 spaces. I don't know if that's true, guys. I just made that up. All right. Where's my teal marker? This says divide by 2, then square. What do I divide by 2 and square? This middle term, right? Divided by 2 is 3. That 3 is going to come back, right? When I factor it. So I'm going to keep that written down, square it, and get 9. Right? Divide by 2, square it. Some people, if you get good, once you square it, you just throw it right in that box, right? Because that's where it's going to go. That 9 is going to go into that box. Divide by 2. It's negative 2. Keep that negative 2 in the back of your head. Square it is 4. Divide by 2 and square it. Divide by 2 and square it. Now, what do I do with that number? I'm going to add it. I'm going to add it. But then I also have to add it to this, right? We're just solving. This is a way to solve quadratics using algebra, because you're using nothing but algebra. You're adding the both sides. You're factoring. There's no quadratic formula. There's no trickiness. And then I'm going to factor and win. What's this whole thing going to factor into? You use this term, right? X plus 3 squared. And then y minus 2 squared equals whatever that is, 21, 25. There you go. Oh, you guys can try the ones on the worksheet now. So, this was out of focus. So if you worked on the AI slop worksheet, those are going to be your answers for it. And that's what I got today.